Hello class, today we are going to be discussing the second half of section 2.8, which covers dimensional analysis. At the end of the lesson, you will have strategies for converting quantities and measurements from one unit into other units. Dimensional analysis is just the fancy name for the process of converting units. This right here is your conversion chart. My recommendation to you is either to screenshot this or go into Google Classroom and download this, this image that I will have posted along with the video. I will give you a copy of this sheet in class. I will only print out one for you, so if you lose this, it is your responsibility to get another one. You need to make sure that this does not have any writing on it for your use on the test. If I see anything written on it other than this exact image, I will not allow you to use your sheet on the test. So we need to convert 6 miles into kilometers. Again, you're going to want to have that chart printed out or screenshotted so you can refer to it throughout this lesson. So we're looking for miles to kilometers. That's going from customary to metric. On the sheet, it tells us that 1 mile is approximately equal to 1.609 kilometers. That's our conversion factor that we are going to use to set up this problem. Your first option is to use proportions. So we got 6 miles over we don't know how many kilometers is equal to 1 mile over 1.609 kilometers. Again, being careful that if you're using proportions, your miles are on top, your kilometers are on the bottom, or vice versa. Same units in the same part of the fraction. Using cross product property to solve, we end up with 6 times 1.609 is equal to 1x, and we end up with a final answer of 9.65 kilometers is equal to x. All of the problems in this lesson today have to have a final label on them. If you do not have labels on them on your homework or on the test, it will be counted as wrong. So you need to make sure you have those labels. So our first option is to set it up using proportions. Our second option is to set it up slightly differently. I like to call them the railroad track method. So you're going to draw yourself a little chart like this. Putting in your initial value, you have still 6 miles to start. This middle line on the track is used to represent per. So if you had 6 miles per hour, 6 miles would go on the top and 1 hour would go on the bottom. Since we don't have anything with per, we can ignore this bottom part. Then you're going to use still this conversion factor of 1 mile is equal to 1.609 kilometers. You can plug 1 mile into the bottom and 1.609 kilometers into the top. When you are using this railroad track method, you want to make sure that your units are diagonal from each other so that they can cancel out. Miles on top, miles on bottom, that cancels out. Then, to finish solving the problem, you multiply everything on the top, which leads us back to our problem there. When you're doing these one-step conversions, it is a little bit easier just to set up the proportions, but this railroad track method will help us further on down when we have more than one unit to convert. Go ahead and try this problem on your own using the mass or weight conversions on your chart. You should have gotten a final answer of 340.2 grams. Again, since there are different conversion factors, you could say 1 ounce is 28.35 grams, or you could say 1 gram is equal to 0.035 ounces. Your decimal place might be off by just a little bit, and that is okay, but you should have the same general answer to 340.2 grams. Next thing we're looking at, the average teenager spends $1,742 per year on clothing or fashion-related items. How much is this per week? So, if you remember back to that first slide, I said that word per is going to come into play when we are setting up those railroad tracks. So, we've got it set up, and we've got our starting values of $1,742 per 1 year. So now we have a value on the top and we have a value on the bottom. It's asking us to figure out how much this is spending per week. So our dollars are not going to be changed, but we're trying to convert years into weeks. If you look back at the chart, it says that 1 year is equal to 52 weeks. So I have to plug that in. Again, you want to plug it in so that your units that you are canceling out, or the units that you are converting, are opposite from one another. And then we multiply to solve. So the top, I get 1,742 times 1, which is 1,742. On the bottom, I have 1 times 52, which is 52. And I end up with an answer of $33.50 per week, or you could say per 1 week if you wanted to put a number on the bottom as well. So we're setting these up now so that there's a number on the top and a number on the bottom while we are converting. Go ahead and try this one on your own, converting 760 miles per hour into miles per minute. You should have gotten a final answer of 12.67 miles per minute. Again, rounding to 2 decimal places. If you had 12.66 repeating miles per minute, that is also okay. Last type of example we are going to look at is skydivers travel at 170 feet per second. If there are 5,280 feet in 1 mile, what is their speed in miles per hour? So we are looking at, again, setting up our track to start. We've got that per. So we've got 176 feet per 1 second. If you are looking at this problem, there are going to be 2 different conversions. We have to get our feet into miles, and we have to get our seconds into hours. The nice thing about these conversion charts railroad track is that it allows us to do all of that before we have to do any of the multiplication. So I'm going to deal with the feet first, since it is my top value. It tells me that in 1 mile there is 5,280 feet. So I'm going to put 5,280 feet on the bottom and 1 mile up top. That allows me to cross out the feet and the feet. Remember, when you have units diagonal from each other, you can cancel them out. Then I'm going to add on a second part to my conversion. I also need to get my seconds into hours. If you looked at that top of the chart, there are 3,600 seconds in 1 hour. So I'm going to put the 3,600 seconds over the 1 hour. Again, we have our units diagonal from each other so that they can cancel out. Even though that unit of length conversion is in between, I can still be using the seconds to hours, canceling those out diagonally. So Now what I need to do, since I have miles per hour, that means that I have gotten to the final unit that I want, and now I need to do the multiplication. So I multiply everything on the top and everything on the bottom. So when I multiply everything on the top, I get 176 times 1 times 3,600, which is 633,600 over 1 times 5,280 times 1, which is just 5,280. And when I divide that out, I end up with 120 miles per 1 hour. So we are able to convert that feet per second into miles per hour. Go ahead and try this problem on your own. You are going to need to figure out how to get feet into inches, and then inches into centimeters, and then seconds into hours. So we converted our 900 feet. There's 12 inches in 1 foot, and then for every 1 inch, there's 2.54 centimeters. And then for our hours, there's 1 hour is equal to 3,600 seconds. Multiply all those values up top, multiply the values on the bottom, and you end up with 7.62 centimeters per second. If you have questions about this or anything else from this lesson, please let me know when you get to class.